this video, we're going to be tackling an absolute classic, the climbing stairs LeetCode problem. And by classic, I don't necessarily mean good. I just mean old. This question is as old as the hills, and it's also a great introduction to the world of dynamic programming. Let's go ahead, let's jump right into it. So in order to understand this problem, you're going to have to do something you probably have never done before. You're going to have to contemplate. You're going to have to think about how exactly can you climb a set of stairs. If you are a normal adult, you probably go up a set of stairs one by one. And this staircase has 5 steps. That is one combination that we can climb the set of stairs. But we can also climb the set of stairs like a little kid as well too. We can skip stairs, or if you're a really tall adult, sometimes you like to skip stairs. And that is the whole entire basis of the LeetCode question. How many different ways can you climb a set of stairs using 1 or 2 steps? And you're going to return that combination as an integer. So one way to solve this problem would be to use recursion. What recursion is going to do is calculate every single possible combination. Very similar to how we would if we were to solve this problem without a computer at all. But notice something very, very important. Once we get to 4 steps, 5 steps, 6 steps, the number of combinations is going to become factorial, comically bad. So bad that if we inputted, say, 20 steps into a recursive climbing stair problem, it would likely exceed the stack frame limit on a modern computer and cause your computer to have a stack overflow. But the bad thing is that in order to understand the correct way dynamic programming to solve this problem, we're going to have to understand recursion. But the good thing is that you don't have to be a recursive whiz to understand dynamic programming. The most important part of this whole entire problem is this part right here. This is the meat. This is the meat and potatoes of the recursive function. This is what's going to do 99% of the calculation. But how exactly does this even work? How does a very simple equation like this going to even produce all of the combinations for climbing stairs? Well, what's going to happen is that it's going to form a tree of different combinations. And at the very bottom of this tree, all you have to do is add all of the numbers together. But how exactly are we going to get rid of this pesky recursion that's going to make our problem factorial? Well, we already know the calculation is doing most of the work. What we're going to do is we're going to extract this calculation out. We're going to put it into a for loop, and we're going to use an array instead of a tree to drastically decrease our time and our space complexity. And let's just solve this step by step. Dynamic programming is all about increasing speed and cutting down on space. In order to do that, we're going to do a couple things. First things first, instead of having that complicated recursive tree where we're doing all of the possible combinations, we're just going to do everything in an array. Second thing is, instead of having the recursion that's going to iterate through everything, we're just going to put everything in a for loop because for loops work better with arrays anyway. And lastly, we're going to cut down on unnecessary calculations by calculating things that we already know. And what do we already know? Well, we already know that 0 stairs is going to have 0 combinations, one stair is going to have 1 combination, and 2 stairs is going to have 2 combinations. Also, with this mathematical calculation, the mathematical calculation that I was talking about before, that's very important. Basically, all this n-1 and n-2 means is take the last 2 numbers, add them together to produce the next number, to produce the next possible number of combinations. So 1 plus 2 is equal to 3. And we're going to do the exact same thing. 3 plus 2 is equal to 5. And that's exactly how we can calculate the next combination, because this problem is based off of adding the previous problems, aka subproblems. So 3 plus 5 is going to equal 8, and that is going to equal the possible combinations of 5 steps. And as you can see, we just greatly reduce the amount of iterations that we need, and we also increase our space complexity. So let's go ahead, let's put this thing into code, and let's hop into IntelliJ. So we are inside of IntelliJ, and the first thing that I'm going to do is create a brand new Java class, and I'm going to call this solution. But feel free to call it whatever you want. Also, I'm going to place this solution class within the same folder where the main file is at. Once again, doesn't matter where you put it. You can put it anywhere, but that's where I'm going to put mine. So let's go ahead and start typing out the method. Now, in this LeetCode problem, we're going to be returning an int because we're just returning the number of possible combinations. Next thing that we're going to do is we're just going to type out the method. The name is going to be climb stairs, and we're going to take in an int. This int for the parameters represents the number of stairs. So let's go ahead. The first thing that we need to do, and this is the case with most dynamic programming problems, is that you want to go ahead and check for 1. If the number of stairs is 1, which is a very big possibility being that this is LeetCode, you don't want to go through all of the necessary steps of creating the array and doing all of the calculations, because it's going to kill your speed. Might not hurt your time complexity, but it's definitely going to hurt your speed. So just like on the whiteboard, instead of doing all of the recursion involved in trees or the tree recursion, what we're going to do is we're going to store all of the values in an array. And basically, this is all you need to do. You create an array, then you go ahead and you populate it with the 1. Now, why are we actually populating this with a 1? We're populating it with a 1 because, number 1, we need the values in order to calculate the next values. And also, every single time we pass in a 1 up here, it's going to equal 1. So we pretty much already know the value. Next thing we're going to do is we're going to do the same exact thing, but we're going to do it with a 2. And we know that if there's 2 stairs, we can only have 2 combinations. Dynamic programming is all about cutting out unnecessary iterations, and that's exactly what we're doing. So next thing that we're going to do, and thank God the AI is picking it up for us, is that we're just going to go ahead and iterate and start filling out our array. And this is where the magical calculation that I was talking about in the recursion problem resides. Now notice something very important about our for loop. It's declared with I3. This I3 means that we are going to start at the 3rd value. Why are we going to do that? Well, let's go back to the whiteboard and let's talk about it. So previously we created our array and we've also populated it with 1 and 2. So what we're going to do is we're going to start at the 3rd spot in the array, and we're going to add these 2 elements. Now, you may not remember, but what we're going to do is we're going to apply our recursive equation just in an iterative format. And this is the spot in our code where we're going to add the 2 previous values to equal the new value. That's exactly what this code is doing. It looks very complex, but really at the end of the day, it's just adding the 2 previous numbers and putting them into the new array that we just created. Then after this, we're going to return the last value. So after we did all of those previous calculations just like this, so we added 1 plus 2, then we're going to add 2 plus 3 is equal to 5. And then in the very last value, this is where we're going to get the actual combinations that we want to return. And that is pretty much it. So let's go ahead, let's copy all this and let's toss it into LeetCode and see what we get. I'm going to take this, go ahead, toss that into the code editor, move this back. We could move that one just forward a little bit like this. Let's go ahead, run our test. Our tests are accepted. Let's go ahead, hit that submit button. We have a time complexity of n, and we have a space complexity of in as well too. We have passed the interview. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. As always, thank you for watching.